Hi guys, today we are going to talk about the division algorithm and how it relates to modular arithmetic, which is really this really fancy formula that we use to find the remainder of a division problem. And the reason we're doing this is there's two reasons. One, it's a 6th grade standard, so you will be tested on this at the, when you take the OAA at the end of the year. And two, because we use modular arithmetic to send and receive messages when we're talking about cryptography. And since that's our next STEM project coming up, that's why we're talking about it right now. The I can statement we're working on is I can use the standard algorithm for division in order to find remainders. So let's look at 73 divided by 2, and let's divide to find a quotient and a remainder. So first thing I ask myself is, how many times can 2 go into 7? And the answer is 3. 3 times 2 gives me 6, and when I subtract, I get 1. Now I need to bring down that 3 and ask myself, how many times does 2 go into 13? 2 goes into 13 6 times. 6 times 2 is 12, and when I subtract, I get 1. So if I want to find my quotient with the remainder, I get 73 divided by 2 is 36, remainder 1. Let's look at another example. 91 divided by 4. First I ask myself, how many times does 4 go into 9? The answer is 2. 2 times 4 is 8, and when I subtract 9 minus 8, I get 1. Bring down that next 1. Ask myself, how many times does 4 go into 11? The answer is 2. 4 times 2 again is 8, and 11 minus 8 gives me 3. So if I wanted my quotient with the remainder, I could say 91 divided by 4 is 22, remainder 3. So how does this apply to modular arithmetic? Well, when you have a problem like the one here, 17 mod 5, all that's telling you to do is to take 17 and divide it by 5, and give your answer is going to be the remainder. So you don't really care how many times 5 goes into 17 evenly. You just want to know that after I put 5 into 17 evenly, what's left over. Okay? So to do this problem, we would take 17 divided by 5. 5 doesn't go into 1, but it goes into 17 3 times. 3 times 5 is 15. When I subtract, I get 2. I stop. 17 mod 15 is 2. And that's your answer. Let's try another one. 25 mod 5, which really just means when I take 25 and divide it by 5, what is the remainder? So I take 25, divide it by 5. 5 goes into 22, doesn't go in at all. 5 goes into 25 5 times. 5 times 5 is 25. When I subtract, I get no remainder. So 25 mod 5 is actually equal to 0, because 0 was my remainder. Now it's your turn. Try finding 7 mod 11. Okay, let's check your work. In this problem, I am saying 7 divided by 11. And how many times can 11 go into 7? Well, 0 times. 0 times 11 is 0. When I subtract, I get a remainder of 7. So 7 mod 11 is equal to 7. Try this one. Okay, so when I take 11 and I divide it by 11, 11 goes into 11 one time. 1 times 11 is 11. When I subtract, I get 0. So 11 mod 11 is 0 because there is no remainder. Pretty simple. Now let's take out our calculators because we're going to get into a little more advanced modular arithmetic, but still, if you're using the order of operations, it still applies here. Now when we get to the modular arithmetic part, what we're saying is that we are going to take 3 to the 4th power and then divide it by 6 to get your remainder. So using the order of operations, exponents come before division. So what I need to do first is 3 to the 4th power, which is 81. And now I just need to say, well, what is 81? Mod 6. So I go over here to my scratch work and I do 81 divided by 6. 6 goes into 8 one time. 1 times 6 is 6, and when I subtract I get 2. Bring down the 1. 6 goes into 21 3 times. 3 times 6 is 18. When I subtract I get 3. So 3 to the 4th power mod 6 is equal to 3. Let's try another. 4 to the 5th power mod 8. Order of operations, first thing I'm going to do is take care of my exponents. So 4 to the 5th power. Now remember, when I raise a number to the power, that's like saying I'm going to multiply that base, 4, the number of times, and the number of times I multiply it by itself is represented in the exponents. That tells me how many times it's repeated. So 1, 2, 3, 4, 5. I'm going to multiply 4 5 times, which gives me 1,024. So now I need to do 1,024 mod 8. So I come over here to my workspace. 1,024 divided by 8. 8 doesn't go into 1, but it goes into 10 once. 1 times 8 is 8. When I subtract, I get 2. Bring down another 2. 8 goes into 22 2 times. 2 times 8 is 16. When I subtract 22 minus 16, I get 6. Bring down the 4. Now I say, well, how many times does 8 go into 64? The answer is 8, which gives me 64 here, and my remainder is 0, so 4 to the 5th mod 8 equals 0. Now it's your turn. Try this problem. Okay, let's work it out. First thing I need to do is 5 to the 3rd power, which is really 5 times 5 times 5, which equals 125. Now I do 125 mod 3, which means I come back up here to my workspace. 125 divided by 3 doesn't go into 1, but it goes into 12 4 times. 4 times 3 is 12. I subtract, I get 0 and bring down a 5. 3 goes into 5 once. 1 times 3 is 3. When I subtract, I get 2. So 5 to the 3rd mod 3 is equal to 2. Now it's your turn. Again, try this problem. All right, let's see how you did. First, I would say, well, 6 to the 3rd is 6 times 6 times 6, which equals 216. So really, I'm trying to find what's 216 mod 10. And over here, I go and I divide 216 by 10. 10 doesn't go into 2, but it goes into 21 twice. So 2 times 10 is 20. When I subtract, I get 1. Bring down the 6. 10 goes into 16 once. 1 times 10 is 10. When I subtract, I get 6. So 6 to the 3rd mod 10 is 6. Let's try one more type of problem. And again, keep your calculators. Use the order of operations. I have 3 times 6 mod 10. The first thing that comes up in this expression is multiplication. So I need to do 3 times 6, which is 18, and then mod 10. Go over here. I can divide. I know you probably know this one already, but we will be using bigger numbers when we do our project. So 10 goes into 18 once. I'm going to still work it out so you have this to refer back to. I get a remainder of 8, so my answer is 8. Now it's your turn. Go ahead and try this one. All right, let's check it. 4 times 5 is 20, because that comes first in my expression. Mod 12, I come over here, I say, well, what's 20 divided by 12? 12 goes into 20 once. 1 times 12 is 12, and when I subtract, I get 8. So once again, just like the last problem, my answer is 8. That's it for this video. You can go back and watch any part you need to, as many times as you need to, but don't forget to answer the questions that were put into the blog for you.